Hello, am I audible and is my screen visible? Hello, can anyone please let me know if I am audible?
Screen is also visible. You are also audible.
Okay, thank you. So good evening everyone, welcome to this NPTEL live session for the NPTEL course Deep Learning IIT Ropar. So this is the second live session. My name is Learning-IIT. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So in this live session we will discuss some practice problems on week 2 topics which were mostly perceptrons and multi-layer perceptrons, sigmoid neurons. These were the topics that were covered in week 2. So we will discuss some questions on these topics, and if you have any other questions or queries regarding these topics, you can ask me during this session. Okay, so we will start solving some problems, and after that if you have any other questions you can ask. And you can write your answers in the chat. This is the first question. If gz is the sigmoid function, then its derivative with respect to z may be written in terms of gz, as there are 4 options: gz into gz minus 1, gz into 1 plus gz, minus gz into 1 plus gz, gz into 1 minus gz. Am I audible properly? Can you hear me properly? Someone is saying my audio is disturbing. You can write your answers in the chat. Kajal Gurnani says option D, so which is gz into 1 minus gz. Anyone else? I've got only one answer in the chat. If anyone else has computed it, you can write in the chat. Vandana Maharajan says option B, which is gz into 1 plus gz. Okay. So the correct answer is option D, gz into 1 minus gz. So sigmoid function is g of z. If this is the sigmoid function with respect to the variable z, then it is given by 1 divided by 1 plus e to the power minus z. So if we take the derivative of this sigmoid function with respect to the variable z, so what we will observe is that we will get 1 divided by 1 plus e to the power minus z into e to the power minus z divided by 1 plus e to the power minus z. So if you compute it properly, you will get these two factors, this one and this one. So this is exactly g of z, and this part is 1 minus gz. So if you compute 1 minus gz, you will get e to the power minus z divided by 1 plus e to the power z. So the derivative becomes gz into 1 minus gz. So this is the derivative of the sigmoid function with respect to the variable z. Option D is the correct answer. Is there any doubt in this question? Okay. Now question 2. Which of the following statements about sigmoid function is not true? So the derivative of the sigmoid function can be negative. The sigmoid function is continuous and differentiable. The sigmoid function maps any input value to a value between 0 and 1. Which is not true? Which of these options is not true? Samarth says option A, Kajal says option A, Vandana says option A. Okay. Anyone else? Phanindra says option A. Anju Lakshmi says option A. Okay. The correct answer is option A. So all of you have written the correct answer in the chat. So as we already discussed in the last question, so if fx is the sigmoid function, then derivative of this with respect to x is fx into 1 minus fx, and so fx is the sigmoid function, and this fx is ranges from 0 to 1, so 1 minus fx certainly ranges from 0 to 1. So both the factors of this derivative ranges from 0 to 1, so the derivative can never be negative. But for the other two options, the sigmoid function is continuous and differentiable, which is correct. So sigmoid function looks something like this. Sorry, something like this. So this is completely continuous and differentiable at every point. And third option says the sigmoid function maps any input value to a value between 0 and 1, so which is also true. So whatever be the input x to the sigmoid function fx, the output of the sigmoid function would be mapped between 0 to 1, which is also correct. So the only incorrect option is option A, so that is the correct answer here. Now moving on to question 3. How many Boolean functions can be designed for 4 inputs? So 4 binary inputs are there in a Boolean function. So how many Boolean functions can be designed using 4 binary inputs? Kajal says option A. Hari says option C. Sushma Shetty says option A. Okay, so A and C are the two answers I am getting in the chat. Vandana says option A. Okay. Anju Lakshmi says option A, 2 to the power 16. Anyone else? Avinav says option A. So the correct answer is option A. So if there are n input binary input variables in a binary function, so how many Boolean functions can be designed? So there is 2 to the power 2 to the power n. Because if there are n input variables, binary input variables, then there would be 2 to the power n rows in that table, 2 to the power n different combinations of these inputs, and for the output, every output can be either 0 or 1, so that becomes 2 to the power 2 to the power n different output sequences that you can generate. So the different output sequences represent different Boolean functions. So 2 to the power 2 to the power n, this is the number of Boolean functions that can be generated using n binary inputs. So in our case n is 4, so 2 to the power 2 to the power 4, which is 2 to the power 16. 2 to the power 16 is 65,536, which is option A. Now question 4. In sigmoid function, if W transpose X tends to infinity, what is the output of the sigmoid function? So if W transpose X approaches infinity, what is the output of the sigmoid function? Samarth says option C, Vandana says option C, Sushma Shetty says 1, Kajal says C, Avinav says C, Harish says C. Okay. The correct answer is C1. So sigmoid function so for this sigmoid of W transpose X plus B, is given by 1 divided by 1 plus e to the power minus W transpose X plus B. Now if this W transpose X goes to infinity, so this whole index goes to infinity almost. I mean, we can ignore B in that case. If one term goes to infinity, then certainly the whole term goes to infinity. So this becomes 1 divided by 1 plus e to the power minus infinity. So e to the power minus infinity is almost 0. So it becomes 1 divided by 1 plus 0. So that is 1. So option C is the correct answer. Now question 5. For a function fx equals 5x square minus 4x minus 5, we use gradient descent to find its minimum. If the initial value of x is equal to 2 and learning rate is equal to 0.02, what is the updated value of x after the second iteration of the gradient descent algorithm? So this can be a little lengthy. So this is a numerical question. So you have to perform the steps of gradient descent one by one. So we are trying to minimize fx with respect to x. So if you use gradient descent algorithm, in every iteration we will update x based on its derivative value, as we do in gradient descent algorithm. So we update x in every iteration. So what will be the updated value of x after the second iteration in the gradient descent? Says 10. I don't think it would be 10, because of this learning rate 0.02, there will be decimal points in it, so it will be some fractional value, not exactly a round figure. It shouldn't be actually. So there might be some mistake in the calculation. Samarth says 2.64. Okay, let's see. Kajal says 1.424. Okay. Sushma Setti says 0.4. Samarth says 1.424. Okay. Okay, so for this question, first what you have to compute is the derivative of this function that is given to you with respect to x. So the derivative f dash x is 10x minus 4. So now the initial point is x equals to 2. So at x equals to 2, what is the derivative value? F dash 2 is 20 minus 4 is 16. So in the first iteration of the gradient descent algorithm, so it would be x should be assigned as x minus learning rate into this f dash x. So f dash 2 in this case it would be. So this term is 2 minus learning rate alpha is given as 0.02 into f dash 2 is 16. So if we compute this, it would be 2 minus 0.32, which is 1.68. So after the first iteration, the updated value of x is 1.68. So now in the second step, we simply have to replace this initial value of x with the updated value now. So for the second iteration, the starting value is 1.68 now. So and f dash 1.68 we can calculate from this formula. So there would be 16.8 minus 4, which is 12.8 is the derivative value at 1.68. So this x is now 1.68 minus alpha is 0.02 into 12.8. So if you compute this, so it would be 12.8, so 256, then this is 0.256. So 1.68 minus 0.256, I think. So if we subtract 0.256 from 1.68, it should be 1.424 most probably, is it? Yes. So 1.424. So many of them have many of you have written the correct answer. Harish also says 1.424. Samarth said 1.424. Kajal said 1.424. Yeah. So this is how you have to calculate this updated value of x after several iterations. First you have to compute the derivative of the given function with respect to x, which is this one 10x minus 4, and now for the initial point you compute the value of the derivative. Initial point is x equals to 2, so f dash 2 is computed, which is 16. Now this is the update rule for gradient descent. X equals x minus alpha into f dash x. So for the first iteration it was x equals x minus alpha into f dash 2. So for the iteration 1, update rule was x equals x minus alpha into f dash 2, and for iteration 2 it will be x equals x minus alpha into f dash 1.68, because after the first iteration the value of x is updated to 1.68. So this is how you have to compute it, and the correct answer is 1.424. Abhinav also says 1.4. Okay. Does anyone have any questions or doubts regarding this question? Okay, then we can move on to the next question. Which parameters need to be learned in minimizing objective function in supervised learning? Only weight, only bias, both weight and bias, and learning rate. Samarth says option C, Vandana says C, Sushma says C. So the correct answer is option C. So in supervised learning problems, we minimize the objective function with respect to both weight and bias. So we learn both the parameters weight and bias by minimizing the objective function. So option C is the correct answer. Now question 7. For a sigmoid neuron given a single training sample, x equals 0.5 and y equals 1. So this is the input feature and this is the output y. So this contains only one feature and for one data point. And initial sigmoid neuron parameters are w equals to 0 and b equals to 0. What will be the updated value of w after the first iteration of the gradient descent algorithm, assuming learning rate to be 0.1? So we are running this gradient descent algorithm to train this sigmoid neuron on this training data set, x equals 0.5, y equals 1. We have only one training data point. So what will be the updated value of w after the first iteration of the gradient descent algorithm? This question is also a bit lengthy, so it will take some time. Samarth says 0.4375. Anyone else? Sushma Shetty says 0.4375. So for this question, the update rule for the weight value W is W equals to W minus alpha is the learning rate, and the derivative of the loss function with respect to W. So the derivative of the loss function with respect to W is given by for the sigmoid neuron it uses the mean squared error loss. So if we take the derivative, so that is shown in the video lectures. So it is fx minus y into fx into 1 minus fx into x. So there are 4 terms: fx minus y into fx into 1 minus fx into x. So now we have to compute each of these individual terms. So if x is given as 0.5, so f of 0.5, f of x is the sigmoid, so f x is the output of the sigmoid neuron, so that is given by 1 divided by 1 plus e to the power minus w transpose x plus b. So the initially the w and b, these two values are 0, so whatever be the x, it would be 1 divided by 1 plus e to the power 0, which is half, which is 0.5. So the fx is 0.5 and y is given as 1. So y is given as 1 here. So now now we can put these values into this derivative equation. dl dw is 0.5 minus 1 into 0.5 into 0.5 into 0.5. And so this is the term that comes from here, and alpha learning rate is 0.1 and the initial w is 0. So we can compute the updated w as 0 minus 0.1 into so this dl dw would be minus of 0.5 to the power 4, I think, and there would be minus of 0.0625. so this would be 0 minus 0.1 into, so minus minus plus 0.0625, so there would be 0.00625. So this is the updated w. I hope whatever calculations I have done is correct, because two of you have written 0.4375. I don't know how both of you got exactly same answer. So this is what I can compute from this. So is there any doubt in this question? So I have written the same exact steps here. So you have to use this update formula, and then this would be x equals to 0.5. so fx would be 0.5 and y would be 1, and then this gradient value you have to compute, which comes out to be minus 0.0625, and finally the w.
Can you explain again how we got that gradient value?
So this gradient, the derivative computation is given in the video lectures, I think, isn't it?
Yes, maybe it was
Yeah, this formula is already derived in the video lectures. That so L, the loss function is fx minus y square, I think half of that. Half is taken just to cancel out this 2 from this power term. So this is the loss function where fx is the output of the sigmoid function. So now if you take the derivative of this with respect to w, this is the derivative that you get, fx minus y into fx into 1 minus fx into x. And
Yeah, got it.
and then you have to compute the individual terms in this gradient, fx, y, x, all these terms are already given, so you just have to put these values into it.
Thank you.
Now question 8, exactly same question, but here you have to find out the updated value of the bias term b after the first iteration of the gradient descent algorithm. Here again you have to first write the formula of the gradient update rule. For that you need to know the derivative of the loss function with respect to bias b, and then you have to put the values into it. So this is 0.0125. Anyone else? It's same as previous, but we'll get 0.5 instead of 0.5 okay. So this question, if you understood the previous question, the solution of the previous question, this question would take very little time. So you just have to know the derivative of the loss with respect to b. So similar to b, the w, the b bias term is updated as b equals b minus alpha into derivative of the loss function with respect to b. Now this derivative of the loss function with respect to b is very similar to the derivative of the loss with respect to w. The only difference is that it will not contain the x x term at the end. So it will be fx minus y into fx into 1 minus fx. So there was one extra x term in case of w. See, this x term will not be there, so there will be only 3 factors: fx minus y, fx, 1 minus fx. So this is the derivative of L with respect to b, and now all the other values would be same. So fx was 0.5, y is 1, so you just put these values into it. It will be minus 0.5 into 0.5 into 0.5. So this is minus 0.5 to the power 3. which is minus 0.125. So B is initial value was 0, learning rate is 0.1, and this derivative value is 0.12 minus 0.125. So it would be 0.0125.
Actually, if you substitute b value, if you substitute the given value in the f of x function, it's coming a different answer.
In what function? Hello?
F of x is equals to 1 by 1 plus e to the power of minus wx plus b, right?
Yes.
If you substitute b and x value as well as w value there, it's coming another term.
No, so fx is 1 divided by 1 plus e to the power minus w. So wx plus b, it's actually w transpose x plus b. Transpose is not required. So w is 0, b is also 0, right?
Yes.
So it would be 1 divided by 1 plus e to the power 0.
Done. Clarified.
So it is half, which is 0.5. So this 0.5 comes here. Is it alright?
Done.
Yeah. I hope whatever calculations I have done is correct. You can recheck it. I might have mistaken somewhere, but I don't think I have mistaken. So you can recheck the calculations. But this is how you have to compute the updated values of the parameters w and b. Is there any other doubt in this question? So I have written the solution. So this should be 0.5, x equals to 0.5. This is a mistake that I will rectify later on. This is the updated value. Now question 9. What happens to the output of the sigmoid function as the modulus of x becomes very large for x? So this is the absolute value of x or modulus of x. There might be multiple correct answers in this question. So the output approaches 0.5, output approaches 1, the output oscillates between 0 and 1, the output approaches 0. Vishal Sinha says B and D, Kajal says B and D, Sushma says B and D. Vandana says C. The correct answer is B and D. So absolute value of x becomes very large. That means either x tends to infinity or x tends to minus infinity. So if x tends to infinity, so the output of the sigmoid function would be 1, and if x tends to minus infinity, output would be 0. So that's why it approaches either 0 or 1. So, the option C says it oscillates between 0 and 1, which is not right. The value of x is not oscillating. Only the absolute value is very large. That basically means either it's approaching infinity or minus infinity. So B and D are the two correct answers. Question 10. We have a classification problem with levels 0 and 1. We train a logistic model or the sigmoid model to find out that W0, which is the bias term, this is also called bias B, learned by our model is 20. We want to predict the level of a new test point x using this trained model. So if for the new test point x the W transpose x equals 1, which of these following statements is true? Option A says that we cannot make any predictions. Option B says that the level of the test point is 0. Option C says the level of the test point is 1, and option D says that we cannot make any predictions as we do not know the value of x. Kajal says C, Samarth says B, Vishal says D. Sangeeta says A, Suchita says C. Okay, so the output of this sigmoid would be sigmoid of W transpose x plus W0 is the output to the sigmoid. So the W transpose x is 1 and W0 is given as 20. So sigma of 21. So if you plot this sigma function or the sigmoid function, so this looks like this, and it at 21 it would approach almost 1. For example, if it is 21, the value of the sigmoid would approach almost 1. Sigmoid of 21 would be 1. If you compute it using a calculator, it would come out to be very close to 1, not exactly 1, because the sigmoid function doesn't exactly touch 1, but it becomes it comes very close to 1. So sigma of 21 is the value of the output of the sigmoid model, and it would come out to be almost 1. So option C is the correct answer. The level of the test point is 1. So sigma of 21, and sigma of 21 is very close to 1, so the output would be given as 1. So this is a classification problem. So if it is very close to 1, then output is 1. If it is close to 0, then output is given as 0. So these were the practice problems that I wanted to discuss in this live session. Now if you have any other questions or queries, you can ask me now.
I want to know what is the first and second question. I was not there.
Yeah, I will upload this the video. I'm already recording this session, so I will upload this video, and also I will upload this presentation slides that I am using, so you will get all the questions.
Okay.
Thank you.
Okay, if there are no other questions, then Vandana says, can you repeat the last question? So the last question, sigmoid of W transpose x plus W0 is what we calculate as the output of the sigmoid neuron. This is 1 and this is given as 20. So sigmoid of 21 is the output of the sigmoid neuron, and sigmoid of 21 is very close to 1, not exactly 1, very close to 1. So the output would be given as 1, because in a classification problem the output of the neural network is either 0 or 1. So sigmoid of 20 to 1 is very close to 1, output would be 1. And if this term was very close to, I mean, W transpose X plus W0 was highly negative, in that case the sigmoid output of this W transpose X plus W0 would be close to 0. In that case it would have been 0. So that's why. So basically,
What is this? This in this equation, what is y equal to 1 by x? What is?
so the output of the sigmoid function represents what is the probability that the output is 1, and 1 minus of that is probability that output is 0. How can we find this recording video and preview? So the links will be shared by NPTEL. I think it has already been shared by NPTEL. I don't know if it has been shared by NPTEL or not. So you will get all the links to the video lectures, and I mean these live sessions, and also these PPTs. In the NPTEL portal, in the course web page, there should be one tab called problem solving sessions. Under that tab you will get all these links. I don't know if it has been activated by NPTEL or not yet, but you can check it out in the course web page. Sridhya says it's available. Yeah, it might be already available there. You can find all the live session links there. So thank you everyone for joining. If there are no other questions, then we can end this live session here. Thank you everyone.